Hey everyone, Dave here again. This particular mini lecture is on structural formulae and isomerism. Alright, now first of all what I've got to do is, like I often do, is just give you a little bit of a definition on things. So first of all, when you're looking at a formula like this one here, C2H5OH, this is actually called the molecular formula, right? So really, it's just telling you the type and number of atoms, nothing more than that. But it doesn't tell you anything about the structure. So let me just point out to you that there's also what's called a structural formula. So here's an example. We've got this compound here called butene, and it's got this structure with 1, 2, 3, 4 carbons here. Now, what I want to point out to you is that, for example, let me just get my pen here. For example, this carbon-carbon triple bond here that makes this thing an alkyne, it could in fact have been here and the single bond over here. So if we could just swap those around. When that happens, you can actually end up with a different compound, but I'm going to illustrate that with a clearer example. Alright, so here's my definition. Oh, sorry, I should say that now we come up with a different idea, and that is that we have these things called isomers. So they have the same molecular formula, but they have a different structural formula. Now the best way to illustrate that again is by example. So if we've got something like dimethyl ether and ethanol, they actually have the same molecular formula, but they actually look very different structurally. Let's have a look at them. So here's dimethyl ether. Now, the important point about this molecule is that it has an oxygen sitting here in the middle of it, and that's what makes it what's called an ether. And they have particular properties, one of which is that ethers tend to be quite volatile, and that they form, liquids, I guess, at gas temperature, but tend to evaporate pretty quickly. So over here we've got another compound. This is ethanol. Now you're familiar with this one, of course. Ethanol is the alcohol that's responsible for getting you drunk. It's in alcoholic drinks. The ol part actually refers to this OH group here. So even though these two things have exactly the same molecular formula, that is, they've got 2 carbons, they've got 1, 2, 3, 4, 5, 6 hydrogens, 1, 2, 3, 4, 5, 6 hydrogens, and 1 oxygen, they are incredibly different in terms of their behaviour, both physically and chemically. I've got a little question here: which of these two molecules would be soluble in water? Well, if you look over here at the ethanol, you'll see there's an OH group here. It's not dissimilar to what you'd expect in a water molecule, which is of course HOH. So this can actually form hydrogen bonds in water. And this fact actually makes this particular molecule soluble in water, as you well know. I mean, you can go and buy, for example, a bottle of wine, and it can have, particularly something like red wine, it can have 15% alcohol in it, and the rest is essentially just a few little other molecules to give it taste and flavour, and the rest is just simply water. This stuff over here is absolutely insoluble in water. If you mix this with water, what will happen is it will just settle to the top of the water every time. No matter how much you try, you cannot shake it into solution. So they're very, very different compounds. They have the same molecular formula, but they have different structural formulae. So therefore, these two would be isomers of one another. Okay, the next mini lecture's on biochemistry.